Okay, topic number 3 is implicit differentiation. Remember, implicit differentiation is where you're taking derivatives with things other than simply x. Remember, sometimes we even have things like related rates. We use implicit differentiation. But usually it's going to be with x and y. So this thing says find dy dx at 2, 1, given 2xy minus y squared is equal to 3. So there's no way of solving for y, so we have to do it implicitly. Watch out for the 2xy. This is a product rule, so you got to make sure you do product rule correctly on this. So taking the derivative, I got derivative 2x is 2 times the second, which is y, plus the derivative of y is dy dx times the first gives me 2x. Then I take derivative of y squared, that's negative 2y dy dx, and don't forget derivative of 3 is equal to 0. It's a constant. There's a couple ways you can actually evaluate this thing. We always want to find dy dx at 2, 1. So you could just plug in 2, 1 right now. You get 2 plus 4 dy dx minus 2 dy dx equals 0. When you solve it, you get dy dx equals negative 1. Or you could solve for dy dx. So I factor out dy dx. It was 2x minus 2y. Move the negative 2y to the other side, which is negative 2y. Divided. Simplify, and then I can plug in. Now there is an advantage on this particular problem. For example, a little harder problem, but I can easily ask this. I can ask you at what coordinates does this function or this relation have a vertical asymptote? Okay, vertical asymptote means the denominator would have to equal 0, which would mean that x is equal to y. Well, if that's the case, I can go ahead and I can replace either the y or the x's, work through it. So I'm going to replace the y's with x's. I'd have 2x squared minus x squared is equal to 3. So I get x squared would equal 3. X would equal plus or minus the square root of 3. So we would have vertical asymptotes. It says x equals y. I'd have vertical asymptotes at square root of 3, square root of 3, as well as negative square root of 3, negative square root of 3. So be aware of that. If I want to find a horizontal asymptote, it would be where y at the top would equal 0, which means y would equal 0. I have no horizontal asymptotes. If I plug in y equals 0, I get 0 equals 3. It cannot have a horizontal asymptote. It has vertical asymptotes, but no horizontal asymptotes. Now, the sample problem I gave you originally is a lot simpler, but I can easily ask these kinds of questions, a little more challenging. Kind of question you should be able to expect to see on a free response question if it came up.